Okay, in this video we're going to talk about all the operations that you can do with functions. So that's adding, subtracting, and multiplying. And then we're going to do composition of functions, which is where you take one function and you input it into the other function and then evaluate it. The only operation that we're not going to deal with today is division. That's because that has its own video, polynomial division. The first thing we're going to start with is the sum of two functions. So what do we do if we have two functions that we need to add? So for example, let's say I have f of x equals x squared and g of x is equal to 2x plus 1. Okay, so if I'm asked to find f plus g of 3, this really means, or this can be rewritten as f of 3 plus g of 3. So notice that this 3 is replacing the x that's normally in the parentheses. That's exactly what we're going to do. We're going to evaluate f at 3 and get a number, and then we're going to evaluate g at 3 and get a second number, and then we can add those two numbers together. You do whatever operation is in the middle. There's multiple different ways to do this. I'm going to do it two different ways. So the first thing I'm going to do is evaluate f at 3. So f of 3 equals, instead of x squared, we have 3 squared. So we have 9. G of 3 is 2 times 3 plus 1. Again, replacing the x with a 3 from the g of x equation. Okay, so I evaluate this number, and 2 times 3 is 6, plus 1 is 7. So what I found is that f of 3 plus g of 3 is 9 plus 7, which is 16. So our answer for this problem is 16. Notice they asked us to evaluate an addition of two functions at a number, and we got a number back for our answer. This will always happen. If I give you, let's say, f plus g of x, instead of giving you a number here, if I just give you an x, or a 2x plus 1, or an x cubed, then you will get back an expression instead of a number like we did in this equation. I'll show you what I'm talking about. So in this one, it says add f of x plus g of x. Okay, so that f of x is x squared, and g of x is 2x plus 1. So all I have to do is combine like terms. If you'll notice, I don't actually have any terms to combine, so this is my answer. It happens sometimes. Don't let it freak you out. People will get to this step and they don't know what to do now. Well, we don't have a number to evaluate x at. It's as simplified as it's going to get, so this is the answer that I'm looking for. X squared plus 2x plus 1. So notice that I can rewrite f plus g of x as f of x plus g of x. I can do the same thing when I'm doing the difference of two functions. Now for the difference of two functions, I need to be very careful. We need to make sure that the entire second function becomes negative. So let's say that I have f of x equals 3 of x, and g of x is still 2x plus 1. Okay, so what I'm going to do is ask you to find f minus g of 1. I'm going to do this one a little bit differently, but if you like this notation better, you're more than welcome to evaluate each one and then find the sum. In this one, I'm going to do it all in the same row. Again, it doesn't matter how you do this. As long as you are keeping track of your signs, you'll be okay. So right here, f of 1, that means I'm going to put 1 into 3 of x. So this is 3 times 1. Now I have to subtract g of 1. Now I'm going to put a parentheses here so that I don't mess this up, because this negative is going to affect the whole g equation, or g function. Okay, when I plug this in, here's g of x, it's 2 times 1 plus 1. Okay, now remember to use your PEMDAS rules. We're evaluating a function. We're doing some multiplication in the first step. 3 times 1 is 3, minus. Now we have to make sure to do inside the parentheses first. So 2 times 1 is 2, plus 1 is 3. So we have 3 minus 3. Now, the parentheses didn't really help in this situation, because we had to do the inside math before we can use the negative, but it will whenever you don't have numbers, so just trust me. And then we got 3 minus 3 is 0. So our answer for this equation is 0. So again, I was given a number, and my output is a number. Okay, I'm going to do the difference again, but this time I'm going to do f minus g of x plus 7. So this says to do f of x plus 7 minus g of x plus 7. So instead of replacing the x with the number 1, I'm going to replace an x with this whole thing, x plus 7. Okay, so that gives me 3 times x plus 7, because it used to be 3x for f, minus g is 2 times x plus 1. So instead of putting the x here, I'm going to replace the x with x plus 1, because that's what the problem is asking me to do. I'm sorry, not x plus 1, x plus 7 plus 1. Don't lose your 1 at the end. So only thing I've done right now is replace the x in f of x with x plus 7, and I replace the g from g of x with x plus 7. Okay, now I'm going to distribute and combine like terms, and once you've simplified, you're done. So don't leave it like this, but go ahead and simplify. So the first thing I want to do is distribute this 3. That is 3x plus 21. And then I'm going to distribute a negative 2 here. Take that minus sign with your 2. So negative 2 times x is negative 2x. Negative 2 times 7 is negative 14. Do not distribute the negative 2 to the 1 out here. Maybe I shouldn't have done it this way. I do need to, however, change the sign on this one, because this negative changes the whole equation. So technically, I guess I could have distributed a positive 2 and then distributed the negative, but I did the negative and the 2 at the same time. But I also want to distribute this negative to this 1 here at the end, because we're subtracting the whole equation. That changes all of the signs. Okay, we're going to combine like terms now. So anything that has an x is going to get combined. So that gives me 3x minus 2x, which is x. And then I also have 21 minus 14 minus 1. So 20 minus 14 is 6. Well, we have too many colors out. Okay. Now we're going to look at some examples with multiplication. I lied to you. We are going to do a little bit of division. But it's not going to be long division like it was last time. We're going to do some product here. Just remember, product means multiplication. Now I do want to call your attention, multiplication signs. You can use a filled in dot, right, to imply multiplication. We can use two parentheses to imply multiplication. We can do x times y to say multiplication, and we can use the x as in 3 times 4 to do multiplication. This symbol is not a multiplication symbol. It's very important that you realize that. We're going to use this symbol later, but it's not going to mean the product of two functions. Okay, this time we went back, we got f of x equals x cubed, and g of x this time as 1 minus 3x. So I'm going to ask you to find f times g of negative 2. So we're going to replace negative 2 in the x for here. We're going to replace negative 2 in the x here, and then we're going to multiply these two numbers together. Okay, so I can rewrite this as the multiplication of f of negative 2 times g of negative 2. So I can split that up so it looks a little bit better. I'm going to replace this x here with a negative 2 for the f function, and then we're going to replace the negative 2 for x and g. Okay, so negative 2 cubed is negative 8. We want to multiply it by this inside, but we need to first figure out what this number is. So multiplication goes first. Negative 3 times negative 2 is positive 6. So that becomes 1 plus 6, which is 7. So we have negative 8 times 7, which is negative 56. Again, we input a number, the output is a number. But if I input a function or an expression, let's say just x, then we'll just take f of x times g of x. Now, you could have done f of x times g of x first, and then whatever you got for your answer, you can evaluate it at 2 to do this problem. I do it this way just to keep everything organized. You can do this however makes you comfortable, though. If you've already learned how to do this and you like that method, that's just fine. So I'm going to do x cubed here times 1 minus 3x. Now I'm distributing that x cubed. So x cubed minus 3 times x to the power of 4. Okay, I can't evaluate it anywhere. I could now ask you f of x times of 7, and you could plug in 7 and give me that number, just like we did here. But there we are, we're done. That's our answer. So we should have an expression for an answer, because I gave you an expression. Nextly, we're going to look at quotient. Let's say I have f of x is equal to x squared minus 1, and g of x is x plus 2. I want you to find f of g of 2. So f divided by g of 2. I can rewrite this, just like I have in the other ones, as f of 2 divided by g of 2. This helps me realize that if I plug in 2 for f and 2 for g into g, I can evaluate these functions, and then I'll get two numbers that I can divide. So in the numerator, we have 2 squared minus 1 instead of x squared minus 1. In the denominator, we have 2 plus 2, because we used to have x plus 2, but we're replacing the x with a 2. Okay, so if you evaluate the numerator and the denominator, you'll get your answer. So in the numerator, we have 2 squared minus 1, which is 3, and the denominator, 2 plus 2 is 4. So our answer is 3/4. And then to see what happens if we have f of x over g of x. So this time we're just going to do them without evaluating at a number, so I can show you what happens. Okay. I can break the numerator to x plus 1, x minus 1. It doesn't really do anything for me though, because nothing eliminates. So if nothing eliminates, nothing actually divides, you can stop there and say that this is the answer, or this is the answer. But there is a restriction now. There's one number that doesn't work. If you recall graphing our rational functions, there's an asymptote, a vertical asymptote at -2. So the only place that this isn't valid, this doesn't work, is when x equals -2. So we also have to include in our answer the restriction for the domain, which is x cannot be -2. Okay, now I do need to preface this. I did all of these f and then g. I can ask you G and then F. So be careful on number 3 on your homework. I have asked it in the reverse order. So make sure you read the problem and make sure you understand what I'm asking for. The last thing for this video that we need to talk about is the composition of two functions. When I'm asking about composition of two functions, sorry, just a second. Can't write and talk today for some reason. When I'm asking about the composition of functions, that means I have something that looks like this. Notice here's that little symbol I was talking about, that open circle. Or we can have it backwards like this. So this is f of g of x or g of f of x. So that's how you say that. What it means is I can take g and place it inside of f and then simplify or evaluate that function. And then this one means that I can take f and place it inside of g and evaluate that function. Think of it like those Russian nesting dolls where you have a little one inside of a big one, inside of a bigger one, inside of a bigger one. I'm writing down how you say it right here. It's all squished together. Sorry about that. That says f of g of x. That's how you read that. And to read the other one, it's g of f of x. So we're going to try some of these out. Now this is good for inverses, and you'll see that in my next video. It's how to tell if two functions are inverses of one another. So we're going to try with f of x equals x cubed and g of x equals x squared minus 2x plus 1. You know what, just for the heck of it, let's throw in another one. H of x is x plus 3. So this time I have 3 equations. You usually only use 2 at a time, but you can do more than that. I can ask you to put h and f together, g and h together, f and g together, whatever I want now. What I want to know is, can you evaluate g of f, g of f of positive 2. Okay, now to rewrite, I like to rewrite it. It looks better for me. I like seeing which function is the inside function. If you don't like to rewrite it, you don't really have to. That's okay. But now I can see that I'm going to put 2, I'm going to input 2 into f. I'm going to get a new number, and then I'm going to input that new number into G. Okay, so f of 2 is what I need to find first. I need to find this inside. So if f is x cubed, then f of 2 is just 2 cubed. So f of 2 is 8. Okay, so now I'm looking for G of 8. Because I know that I can replace f of 2 with 8 because that's what I got. Okay, now I can replace the x in the G function with 8, so that's 8 squared minus 2 times 8 plus 1. So, I don't know, 64 minus 16 plus 1. That is 49. So the answer to my problem is 49. Now I'm going to go the other way. What if I instead asked for f of G of 2? Don't mistake this. These are not the same thing. I'm going to prove it. We're going to work this problem out, and let's see what happens. This time the inside function is G. So the first thing I'm going to do is input 2 into G. So I need G of 2, and that is 2 squared minus 2 times 2 plus 1. Okay, so that is 4 minus 4 plus 1, which equals 1. So what I'm really looking for is what's happening when f is 1. So now I just need f of 1, and f is x cubed, so this is 1 cubed, which is 1. So G of f of 2 was 49, and f of G of 2 is 1. So be careful. Just because I give you the same numbers, the same equations, the same number to evaluate, doesn't mean we're going to get the same answer. The order really does matter. Okay, I want to do 1 with an x. I'm going to do 2 with an x, actually. Let's say I asked for G of f of, I don't know why I keep doing that. Goodness. G of f G of f of x. So this is equal to G of f of x. There is no number to evaluate this out at, so we're just going to take the f function, which if I remember was x cubed, and the g function, which is x squared minus 2x plus 1. Okay, so I'm going to take f, and I'm going to replace this x and this x with this whole function right here. So this is equal to, okay, the way I like to do this is write the outside function, and instead of writing the x's that belong in the outside function, I'm going to replace all of them with parentheses. That way, I don't forget any pieces of information, because a lot of people will miss this 1 at the end. So I write at the whole function, replace the x's with parentheses, and now I'm going to write in the function f into these equations. So x cubed, x cubed. Okay, from here, you simplify until you can't anymore, and then you'll have your answer. So x cubed squared, that means there are 2 x cubes here. So this is x to the power of 6 minus 2x cubed plus 1. There's our answer. Now if you remember, I also gave you another equation. H equals x plus 3. I want to show you what happens if I have a binomial inside of this instead. So I want to do g of h of x. So this time, my h of x is going to be my inside function. So I'm going to do the same thing I did in this step. I'm going to write g, and I'm going to leave some space to place in h. So h is x plus 3. So in these parentheses, that's what I'm going to write, x plus 3. Okay, now, people will mess up here. So this is why I wanted to try this problem. Do not distribute this power like we did over here. The only reason that we can do that is because it didn't have a plus or minus a constant. When you have a constant, you have to actually multiply this times itself twice, just like the power says. So I'm going to expand this, and while I'm doing that, I'm going to distribute this 2 here into this function. So we have negative 2 times x, which is negative 2x, negative 2 times 3 is negative 6. Don't lose your 1. Okay, over here you can use the box method or you can use the FOIL method. I'm going to do a little side work so I can work it out for you. That's x plus 3, x plus 3. So x squared, 3x, 3x, and 9. So we're looking for x squared, combine the middle terms, plus 6x, plus 9, minus 2x, minus 6, plus 1. The only thing left is to combine like terms. So we have 1x squared, we have 2 x's that need to be combined, and a bunch of constants that need to combine. Okay? This means my answer is x squared. 6 minus 2 is 4. 9 plus 1 is 10, minus 6 is 4. So there we go. That's our answer. Okay, you should be able to do all of your homework problems. If you need any help, please reach out.